So find the derivative of this function using the limit process. So what happens there, we're going to use this limit process. I know there's two of them, but we're going to use this one. All right, and find the derivative function, or the slope generator function. So what we do here, your a value is x. So I'm going to kind of rewrite this thing, all right, is the limit as h approaches 0 of the function, but I'm going to put an x here for both these spots. So what we're going to do is we're going to plug this into the function. So what I have here is, first of all, I have 3 times x minus 2. All right? And that, what am I going to plug in is this whole thing is going to go right here. So right here, I'm going to put x plus h right there inside of that. And then we have minus the function 3x squared minus 2. Now the reason for that is f of x. See, f of x is just that. So f of x goes here, and this is f of x plus h. So I put x plus h inside of f of x. All right, and then bottom is just simply going to be h. So we now are going to find this limit. You might be like, how do I do that? Well, watch what happens. So we're going to keep the limit sign as h approaches 0. And we're going to get 3, and then we're going to FOIL out x plus h times x plus h. So we're going to FOIL that out. If we multiply it out like this, we'll end up with x squared plus 2xh plus h squared minus 2. All right, and then we're going to distribute this negative. That gives us negative 3x squared plus 2. All right, and this is all going to be still over h. Now, I might be wondering why we're doing all this. You'll see as time goes. It's interesting how this all works. All right, so now I distribute the 3. That gives me 3x squared plus 6xh plus 3h squared. I'm going to cross these out because they cancel each other's out. And then I still have the negative 3x squared all over h. Okay, so next, what do I do next? Well, what I notice here is I notice these cross out. So I now have the limit as x approaches, as h approaches 0 of what's left is 3xh plus 3h squared over h. Now, I still can't plug in 0, because if I plug in 0, I still have a denominator of 0. So, but can I factor the top and try to cancel out h? Watch what happens. This is the limit as h approaches 0 of, pulling h out, doesn't leave me 3x plus 3h over h. And won't these h's disappear? Leave me the limit as h approaches 0 of 3x plus 3h. Now, can I simply plug in 0 for h, and I get 6x plus 3 times 0. So my answer ends up being 6x. So what does all that mean? Well, this is the derivative process. The limit, using a limit to find the derivative. So weren't we finding the derivative of this? So here's how you write it. The derivative of f of x is equal to 6x. We just took a derivative of this. This function, for any number you plug in for x, will give us the slopes at any point on this graph. And we did this long whole process to do it called the limit process. We're just doing this. Again, we put in x for h, for a, and then we put x plus h into the function here. We just left x regular, and then we crunched it all out, and then we always pull out a GCF. The h's disappear. It always works. It's kind of neat. And then we simply plug in our 0. When we plug in our 0, we get our function for our derivative. This is not a process we'll be using very much, so don't freak out. We go to very good, quick, and easy shortcuts. This is just showing you how the limit process does lead to a lot easier process.